All right, well, welcome back. So, as I have alluded to a few times throughout the last couple of sections, we are about to jump into the awesome world of regular languages as well as some regular expressions. So, down at the bottom, I got this nice little picture of where we are currently at in this world. So, we have this, I don't know, square or rhombus or rectangle, or maybe you view that as a circle, which kind of showcases a bunch of the things that we've happened to be looking at. We actually started this little game by building up some of these deterministic machines. Then we expanded that a little bit to looking at the non-deterministic ones. Then we just got done adding in the secret little teleporter, these little epsilon transitions. And now we're actually going to bring about some regular expressions and nicely connect this little wheel or this little diamond. So what I mean by that is we've seen these kind of things on the right-hand side kind of give rise to a variety of different types of languages. The idea is that if we have a language that was generated from one of these non-deterministic machines, we could actually rebrand that thing in a deterministic fashion by constructing a new little machine. What we're going to see here is that all of those things that we've been able to create can actually be created with these nice little regular expressions. So they're actually all talking about the exact same stuff. So that fancy stuff then gets a nice little name. That name is then going to be regular languages, which should hopefully scream at you saying that there are going to be things that are non-regular, and we'll chat about that in a little bit. But for right now, these regular languages are going to be these things that are recognized by some nice little finite automaton. And that's it. That's all our original definition is going to be, that languages are going to be regular if they come from some nice little machine. What that should also kind of begin poking at your brain is, if you hand me some nice little language, how do I actually go about trying to identify if that thing is regular? Well, one of the things is you can try to build a machine to then match that thing, or we're actually going to be able to see if we can align it with some nice little regular expressions, then those worlds are going to meld together as well. So as I alluded a little bit already, is this question about, do we actually have some non-regular languages? And the answer to that is yes. We actually poked into it a little bit on your very first homework, the one where you were trying to build some nice little machines that played with palindromes. And originally I kind of set it as like, okay, try to play with palindromes of length 3. Like, okay, that's not so bad. I got this kind of nice little hexagon and everything is great. And then I was like, okay, what about palindromes of length 4? And you're like, okay, that's a little bit bigger, but I can still technically do it. Officially had some bonus ones that said, okay, try to go a little bit farther. So if you were to build a machine for palindromes of length 5 or 6 or 7, you would start to see that this machine is going to grow. It's going to get bigger and bigger and bigger. And then it begins to just blow up if I were going to allow this thing to work with any type of palindrome. So there's not a finite machine that would actually accept all of these nice little palindromes. So that's one kind of early example of something that is not achievable in this world. So we kind of have an upper limit of what these models of computation can actually do, which is then going to drive the point home as to, we need extra cool things to be able to kind of really see what this world is all about. So more about that in a bit, but that's kind of where we're going to be stepping. So we have this kind of upper ceiling, and then we're going to blast through that thing and then begin looking at all kinds of crazy stuff. So regular languages are going to be the things that emerge from these cute little machines. We're going to have a really nice result that says these languages are going to be regular if and only if we can actually connect them to a regular expression. So that was back to our little picture that we had here, is everything that we've been talking about is in fact regular. Now we can actually begin viewing them via these regular expressions, which you may have already seen a little bit depending on your background in programming. So now we can align all of these things together and everything is awesome. Cool. So before we begin kind of fully ripping off the Band-Aid that is regular expressions, I just want to remind you about some little pieces that we already have in our back pocket that are actually going to be used as we build up some of these regular expressions. So the first thing is going to be this notion of this little star operator. So the star, if you remember it, is going to take all of your characters in your alphabet and it's going to begin creating words out of whatever things you happen to work with. You can take as many or as few of those entries and you begin kind of smashing them all together. So if I were to look at an alphabet of just 0 and I take 0 star, what that's going to be is just any word that you could ever make out of just zeros. So 0, 0, 0, triple 0, quad 0, 7,462 zeros, as well as no zeros at all. What you do is grab some zeros, glue them together. Same thing happens when I were to increase the alphabet to not just having 0 in it, but 0 and 1. So fancy, we have 2 things now. What we can do here is we can create any nice little combination of 1s and 0s as I ever want. So I take 2 1s and 1 0 and I glue them together, and hooray, I have a new little string. Officially, this idea of gluing them together has a fancy name. It's referred to as this notion of concatenation, which is probably a term you've heard in some programming courses in your past, which is take your favorite strings, glue them together, and everything is awesome. Some programming languages are really nice when it comes to concatenation. If you think about Python, you just throw a little plus sign between things and hooray, they get glued together and everything is super duper tight. That's actually going to come into play a little bit later because this concatenation is going to be one of these regular expressions as well as this little star. It's kind of why I'm dwelling on it right now, is because it's this idea we actually have some of these things already. So it's not all brand new in that we're actually going to kind of cycle back to things that we already know and love. Once we have star, I do like to bring about another operation that we will make use of, which is going to be the plus, which looks very, very similar to the star, except for it does not allow that empty string to be part of the party. In that I'm going to begin grabbing things and jamming them together, but I have to at least grab something. So 0 star allowed for empty, as well as 0 1 star allowed for empty. But if I look at 0 plus, then the kind of smallest thing in this list is going to be the singleton 0, which happens to have length 1. So that's going to be this idea of at least 1 0. Or in the 0 1 plus, it's going to have at least 1 character, whether it be 0 or 1, or I could have a whole bunch of other stuff as well. So the plus is a slight modification to the things that we already know and love. A couple of the other key operations that we're going to be working with, which are referred to as the regular operations, are the following 3. So what's cool about these regular expressions is that they're essentially going to be built up very minimally, because we're going to have essentially the fewest number of operations possible to then just give rise to this massive world. Once we dump it into the application world, we're going to begin adding in a few extra symbols and things to make my life a little bit better. But if you want to go from a pure minimalist point of view, all you really need is some notion of unions and concatenation, and then this star operation. Once you have that, you can build any of these things. But when it comes to full implementation of regular expressions, we usually like a few more. So the 3 big ones, as I alluded to already, are exactly that. So union, which is going to be the notion of an or, so a Boolean or. Concatenation is going to be this idea of gluing things together. And then the star is, well, the same star that we've had before. Officially, we've been defining these things via just over an alphabet. We can technically begin defining these things over full languages. So the union operator is going to have a language A, which we can actually think about honest to goodness languages. So let's say the English language is A, and then B is going to be the Spanish language. So if I combine those with the union or with this or, what's going to happen is that I'm going to create a new language, which I'd call A union B, or A or B, which is going to be everything in list A, everything in list B, all in one super duper big list. So we have all of the English words living there, as well as all of the Spanish words as well. So the union operator is super duper easy to work with. You're just gluing them all together and everything is awesome. The concatenation is the one that starts to get a little bit more interesting. So here I got a couple of some nice English words. So I have yay, which I use over and over and over again, as well as just yes, because I could easily convert that into a Spanish one. I have the word cyber, just because it's fun to throw that one in, and it has a fancy Spanish equivalent as well. And then I got sick of writing English words, so I just did comma, dot, 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 dot. So the B list, so the Spanish, I have C, so yes, as well as cybernetico, which is cyber in Spanish. So if I were to take the concatenation of these 2 languages, so I'm going to take A, B, what happens is that I'm going to form a new language where all of the words here are going to be weird gluings together of an English part and a Spanish part. So I would take like the yay from English and the C from Spanish to get a new word that has 5 characters of yay-see. We could also get yes and C to get yes-see. We could also get cyber and C to get cyber-C. We could also get yay in English and the cybernetico in the Spanish to get yay cybernetico, and you can get this crazy bin of concatenation. So it's kind of a weird operator, but it'll make a lot more sense once we actually get to building some of these regular expressions. But I like to throw it back to an honest to goodness language discussion because it's kind of cute. The star then is, well, it's the same star that we had before, in that you could begin creating new words out of the words that we already have. So if you were to take a star, you could have like yay, 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 yay. There's like 5 copies of the word yay. You could also get like yay, cyber, yay, cyber, yay, cyber as a word in that new bin as well. So take any of the words that you have, glue them all together in whatever kind of configuration you'd ever want to work with. Cool. All right. So let's jump back to some kind of other little baby list in case the English language, Spanish language example was kind of funky. Let's just honestly look at some binary strings over this alphabet of zeros and ones. So here I have 4 cheesy little languages that have very few words in them. It's kind of like a baby's language, and that language A is I know exactly 1 word, and the word is 0. So a little kid who only knows no. B is then going to be the language of I only know 1 word, and the word is yes. C is then the language of having 2 words. Word 1 is then 0, 0. Word 2 is then 1, 1. Language D then is also 2 words, so 0, 1, and 1, 1. So unions, again, are super easy. We're just going to be jamming these things together. So if I were to take A and B and combine them, I'd get the 0 coming from the A, the 1 coming from the B, making a new list of 0, 1. If I were to do the A and the C, well, you take the thing from A, you take the stuff from C, create a new list out of them to have 3 little words. If you begin taking C and D, things become a little bit more interesting because they have a shared term. They both happen to have an 11. So you could think about C union D as being, well, the 0, 0, the 1, 1, the 0, 1, and the 1, 1. Technically, we have a little bit of repetition, so it's not adding anything new. So at the end of the day, I could write it with the repetition, or I could chop off the other one afterwards. So that word 1, 1 could like make an appearance twice in my dictionary, or it can make an appearance once, but it's part of this language. So that's the union, or the OR operation. The next one then is going to be playing with these ones and concatenation. So A, B concatenated with themselves. Well, you're going to build new words with words from A, words from B glued together. Well, A only has 1 word of 0, B only has 1 word of 1. So when you glue them together, you get 1 new word of 0, 1. If you take A and C and concatenate them, what's going to happen is you're going to take the only word from A, and you're going to take the 2 different words from C and then glue them together. So what's going to happen here is you're going to start to see, hopefully, some of these machine connections come into play. Is that A concatenated with C is going to require every word to start with a 0, because that's what A is coming with. A's got the 0, followed by either 0, 0, or followed by 1, 1. If you take C and concatenate it with D, now you're going to start getting kind of some crazy crisscrossing things happening. So you could take the 00 from C and then glue it to the 2 things from D. Or you could take the 11 from C and glue it to the 2 things from D. So at the end of the day, you're going to get 4 total entries emerging. So it's kind of this weird way to begin combining things, but it'll all start to build up once we get into the regular expressions, kind of ripping off the whole thing and seeing what happens. For these ones, we might as well chat about the star operations too, just because they're kind of cute. So A star is the same A star that we've worked with before. It's 0 and then star. So take as many zeros as you'd ever want. C becomes a little bit more interesting because my language has 2 things in it. So when I take the star of it, I get a slightly more interesting list of things. I also get a word that's really fun to say. I was in my face-to-face class and I said it, and then I had to pause on it because it just rolled off the tongue kind of cutely, in that we're computing C star, which I had said is sounding a lot like some underwater animal, that it's a sea star. So hooray! That's also really fun to say. So I recommend saying sea star over and over and over again because it's kind of cute. So anyway, sea star, just because I wanted to say it one more time, is going to be any combinations of 00 and 11, as many or as few of them as you ever want. So you have empty, you get the 00, the 11. You maybe can take 2 copies of 00. You can have the 00 and the 11, and you can combine them in either order. You can have quad ones from 2 copies of 11. You could have 6 zeros coming from 3 copies of 00. But the thing you'll notice is that I will always have two zeros next to each other and two ones next to each other. I'll never have a single zero or a single one. They're always going to come in pairs because that's how they had to come. So it's the thing we'll begin seeing as we try to build these machines that have, an even length or acquiring double zeros or all of that kind of stuff. It's going to kind of nicely snowball and play very nicely. As we begin to morph into all of the goodies that are regular expressions, we're going to start shorthanding some of these things up. Basically, if my language only has a single character in it, I typically will draw just as a zero. If my B has a single character in it, I'm just going to draw as like the one. My or, so this union operator, is a nice little operation, but it's crud to draw or use on a keyboard because that doesn't exist as a nice little keystroke. So what we typically do is then we're going to do this Boolean or, and we're going to run it with a vertical line. So rather than writing A or B, this union operation, we're going to write this as A or B with this vertical bar. So if you think about taking A and B there, it's going to be 0 or 1. So it creates this new little list of 0 or 1. So we typically will shorthand that as just this little 0 or 1. And we'll see that expression expand a little bit farther. Same thing is going to occur in the concatenation. So if I were to have A, which is just 0, and B, which is just 1, when I take AB, it's then going to become this single little list, which contains 0, 1. So just as we get into things, we're going to kind of drop some of the set structure and then just bring in the regular expressions and make our lives a little bit easier. So that's the kind of really quick overview of some of these operations. In the next video, we're going to jump into kind of properly identifying what the regular expressions are and then begin building a whole bunch of them based off of some of the machines that we know and love.